So there we go. So it would be this is an intermediate step here. And then I just turned it around. Because if A minus P over PR is equal to T, then we can put it like that. That's the more traditional way. All right. So here's another one. So this is the one that's called the area of a triangle. So solving for B. Now what I would do on this one, it's just to clear that fraction, I'm going to multiply both sides by 2. So 2 times A. And remember, this is 2 over 1. And so this is why this goes away. So you got 2A is equal to BH. And then we're going to get rid of that H by dividing both sides by H. So that's 2A. All right. So questions? All right, so we got to solve next an inequality. We're going to essentially just do what we usually do on an equation. So first of all, those can be put together and these can be put together. The X is on the left and the numbers on the right. So that's negative 13X plus 10. And then over here, 8 and 10 is 18 minus 15X. I'm sorry, this is a less than, and it's not it doesn't have an equal to underneath it. So I'll fix that in the next round there. I just can't, like I said, I don't think I got an eraser on this thing. At least not that I know of. Anyway. So now let's add 15X and minus 10. So that's going to be 2X. And this is 10 is equal to 8. Oops, and I'm putting equal again. It's great, it's less than. So it's X is less than 4. There's no equal sign, so that's important. Now we can make whichever one of these we want is 4. I'll just make this one 4 here. And then I'm going to graph. All right, that's the graph of it. The interval notation. Just got to remember, this thing is headed towards the left side, all the small numbers. In other words, the infinity over there is negative. And then over here it's 4. And because there's no equal sign, we use the parentheses. Okay, questions? All right. So on this one, we got to do a little bit on the right-hand side before we can collect any like terms. So it's going to be negative 18. All right, and y'all can chime in on these. I don't want to be the only one. So if you got something, just type it in, all right? This is less than or equal to now. 6 negative times 2 is negative 12x. And negative 6 times 2 is negative 12. All right, now we're going to collect. Put the variables over here and the numbers on the right. So that means I want to get rid of this one. And this is going to end up being one that gets twisted around. Those are going to be gone. These are going to be gone. And we left with negative 6x is less than or equal to 12. Now, here's where we got to watch out. It's an inequality. When we introduce that negative sign here, it turns this around. So x is greater than or equal to negative 2. So let's just say negative 2 is right here. We're going to need a bracket, and we're going in the direction that that pointer is pointing, that inequality. All right, so we're going to use that same symbol right here, that bracket. We're going to put the negative 2, and we're going in the direction of the inequality. All right, on that right side, and the same way that these arms are going, is the positive infinity. And that one has always got a parentheses. Infinity always has a parentheses. All right, any questions about that? All right, now this is a compound inequality, and it's compound because it's got 3 parts. It's implicitly called an and, but we don't really have to worry about it if it's written in that 3-part. So what we do, though, is, anybody remember? And this is one of those that's going to turn around. I really kind of wish they didn't move these, but. All right, so we're going to work on the center. And what we do to the center, we got to do to the other 2 sides. So see, those are gone, and we got negative 3x, negative 6, and then this is negative 18. And like I said, I really wish they didn't make this negative in there, but it's not that bad. It's just that it's kind of strange what happens. It just turns the endpoints around. So when we do that, we got to remember to turn both of those things around. In other words, so say both of them turn around. And this is 3. All right. Now, the problem is it's backwards, but if you got a little bit of imagination, sort of like a mirror image, essentially what this is if we just kind of turn it around and keep the signs pointing, so the arrow is still going to be pointing towards the 2. And then the arrow is still going to be pointing towards the X. Now it's back like it should be. So there's the solution. It's between 2 and 3. I mean, this is correct too. It's just that you're reading it backwards, which kind of creates a bit of an issue. So I'm going to just so this one's a bracket here, and then this one's a parentheses. So that solution is everything from 2 all the way up to almost 3. There we go. So let me know if you got any questions on that. All right. So what about that next one there? Any ideas? All right. So here's another one that's compound. I don't know why they have to turn 2 of these. Anyway, so we got to just work on these separately. Still don't leave us a whole lot of room. So on that one, it's negative 7x greater than or equal to 14. On the other one, it's the minus 3.
It's going to be negative 4 and negative 2.
All right, that sounds good. You're way ahead of me. Let me just check here. All right, and since this one is negative, this one's going to turn around. So x is less than or equal to negative 2. Is that what you said? So here's the solution algebraically. If we want to do it on the map, on the graph. So let's just put negative 2 right here. And then negative 4 right there. All right, this one, these are both got an equal sign. So that means on this one, that's a bracket going down that direction. On this one, it's going up that direction. Now, this is probably the stuff that most people are having trouble with. I'm going to write it down here because there's already enough room there to do it justice. But anyway, we're going to have the -2 there. And it's a bracket because of the equal sign. And the direction that arrow is going, the same direction that the little arms are pointed, is going to downside, the less than, the negatives. So that's where negative infinity is at. Infinities always take a parentheses no matter what, because we never get there. You cook these two together, the or with that u thing. And then this is going to be the -4. And then we're going now to the positive side, which is the positive infinity. And again, infinity always takes that symbol, the parentheses. Yeah, it's going to be hard to squeeze it in there, so just pretend that it's up there. If I were taking this test and my teacher was a stickler, I might circle it and then put an arrow right there, because it's really not enough room to get it in there. All right. Another or. So I bet you on one of these, you're going to have something turn around, maybe. No, we had a turn around up there, so maybe these will be normal. So on this one, well, yeah, that one's going to turn around. 6x is less than 2x plus 4. So this is going to be 4x is less than 4. X is less than 1, because we're dividing both sides by 4. All right, on the other side. All right, this one there's nothing to really collect, but we're going to have to do that turnaround thing because this variable is negative. So when we divide by that negative number, which is the same as multiplying by negative number, this turns around. That's 3, and this is x. So all right. So that's another one. So let's just say this is 1, and this is 3. So it's going to be pretty much just like this one. Anytime you have an or, they're going to be separated. It's a bracket, and this one's a parentheses. So again, you're putting these two together with the u. This is the bracket side. This is the parentheses side. 3 goes here. 1 goes here. Comma, comma. This is your positive infinity. Always takes the parentheses. This is a negative infinity. Any infinity always takes a parentheses because you never get there. So there's a solution to that. Any questions? All right. Well, if this thing had like the revert to back up one thing, this would be a good one. I just don't see anything to undo like a mistake. I know I can click down, but it'll remove everything. I tried it already. So, all right. So now this next one is going to simply be points, putting points in. All right. So they're providing the x's, so we just need to put those x values in and find out what the y is in each case. So let's say x is equal to 6. So that means 6 minus y is equal to -3 minus 6 minus 6. So it looks like it's going to be what? I want to hear one of y'all tell me. Because this is negative, it's going to change the sign, because we essentially going to introduce a factor of -1 in order, because we got to have positive y. And so we do the same thing to both sides. So we multiply this by -1 to get rid of that negative y. And we do the same thing over here. So 9. So now we're just going to put a -4 right there for x. See what it comes out. Here we're going to add 4. So negative y is equal to -7. Hold on a second. Did I do that right? Negative. Oh, I messed up here. Sorry. It's got to be the same thing. So this is just going to be a 1. What's that last one? 0 is usually the easy one because you can put in, and it takes away one of the variables and makes your life a lot simpler. So that means minus y so same thing, since it's a negative y, multiply both sides by -1. All right. So let's put those points on here. All right. So 6, well, let's put 0 and 3 is 1, 2, 3. All right. That's this one right there. That was the easy one because that's the y-intercept. Now 6 and 9, 1, 2, 3, 4, 5, 6, and then up 9. Whew. 1, 2. Okay, I think that's 9. And it looks pretty good. And then the other one is -4. 1, 2, 3, 4. And -1. And that looks good. They're all straight in a line. Three points all in a line is a good thing because it tells you you've done things correctly. If one point was out here, then I would, you really have to check all of them at that point, but just go back and make sure you didn't make a mistake, because you can draw a line through any 2 points, even if 2 of them are not done correctly. But for example, if you had these 2 and this other one was over like down here, then that might be just a case of you put it in the wrong spot. But you have to go back and check. So there's nothing we can put up there because it was a graph. All right, so this is why I was telling you that being able to solve for y on one of these type equations, the ones that are in standard form, is important. Because this is how you get it in the y is equal to mx plus b format. We want to get it solved for x. And if we get it solved for x, then we've got the slope and the y-intercept. So what we're going to do first, I'll just write that up here. So that's going to be negative 12 y is equal to negative 6x plus 36. Then I got to take care of this. I got to divide both sides, but all of them, both sides, all three terms by negative 12. Okay, so we got to reduce that. First of all, negative over negative is positive. 6 over 12 is 1/2. So there's our slope. And then this is negative 3. Am I right? Y'all doing okay? Y'all still alive?
Yes.
Okay, good.
Yes.
All right. So does that look good? No questions? All right, so let's move on and see what else we can get it. Oh, we want to graph this. So and another reason why this form is important in being able to solve for y is when it's in this form, you can use the rise over run method for graphing. So this tells you a free point. That's the 0, negative 3. Right there. 1, 2, 3, negative 3. And then now we can just rise or run. We're going to rise up 1 and then run. And since it's positive, we go positive both times. There's your other point. And you can see that that's 1, 2, negative 2. And then the line goes through it. All right. Again, there's nothing we can really put up there. All right, so this is one where you're just going to find the 2 points. You're going to have 0 for y in order to get the x-intercept. And for the y-intercept, you put 0 in for y. So that's what we're going to do. We're going to have x. I'll do this one first. Put x is equal to 0. So when I do that, this is going to be gone, and I'm just going to have 6y is equal to 6, which means So that's going to be right there. So the other one is y is equal to 0. And that's going to tell us our x-intercept. So this is going to be gone, all right? And you're just going to have negative x is equal to 6. And again, since this is negative, then we essentially just change the sign of both, which is x is equal to negative 6. All right, so let's put those points on the graph. I don't want to do that yet. All right, so we're going to put, so negative 6, 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's right here. This is kind of neat the way this one works. All right, and then 0, 1 is right here. And there's your graph. All right. Now, one of the things when you're graphing these special types, either the x is equal to or the y is equal to, you got to remember, it's helpful to remember which one is the vertical and which one is the horizontal. When x is equal to any number, in this case 3, we're simply going to go over here, 1, 2, 3. And so what that simply means is that any one of these points are on x is equal to 3. All right. This is the one that's called undefined if you want to know about the slope. So let me just write in here. To just kind of show you. See, this point right here is 3. And then this is 1, 2, 3, 4. See, it doesn't matter what the y is, the x is always 3. See, the y is changing, but the x never changes. So that's why we say that x is equal to 3. All right, and then the slope for this is undefined. Vertical line is undefined. And you could easily check that by using any of these points on the line to calculate the slope. If you were to do that, there's going to be 2 3s in the denominator on your slope formula, which is going to amount to 0. Anything in the denominator that's 0 is undefined. And this is the horizontal line. Go up to 1, 2, 3, 4. All right, so that's y is equal to 4. Any line on there, any point on there is going to be y equal to 4. So for example, on this one right here is 0, 4. Oops, I'm sorry. Yeah, 0, 4, because there's no movement on the X. This one right here would be 4, 4. And this is negative 4, 4. The only thing that's changing is the X. The Y is the constant value 4. We calculate the slope. The numbers that are going to take each other out are in the numerator now. So 4 minus 4 in the numerator is 0, and that's a slope of 0. All right, any questions? All right, so you got to remember these formulas. I mean, which formula to use for what? So here's the formula for the slope. And it's incidentally just, it's the same formula. Ah, shucks. I didn't leave myself enough room to put it on the top. All right. Let me put it over here. So this is the slope for the formula. All right. So now, it doesn't matter which one you use. I like to mark them. All right, so that way I can just pop them in there without thinking about it. So it's -1 minus, that's built in, that negative sign. And then it's going to be another -1, right? And then it's 3, this minus built in. So if there's another sign, then I got to do this. I got to minus a minus. Now what's going to happen up here? I think we got a slope of 0. And just to kind of show you how it relates back up to number 15, see how in the Y position those numbers are repeated? Well, that's another indication if you caught on to that before you went ahead and did the calculation. They're exactly the same. Y is -1 on both. So what's going to happen when you subtract they're going to be 0. All right. Hold on a second. I was trying to. So another slope. So we're just going to use that same formula. These are the same, but now they're in the x position. So what do you think the slope's going to be? So this is -6. And that's -2 plus 2. It's really just the opposite of this, except now it's 3/0, which is undefined. So undefined, just put that right there. All right, so remember the whole parallel and perpendicular? Well, first of all, let's just make the point that these two lines are perpendicular to one another. Say this is one that's got slope undefined, and this is one that's got slope 0. So this one is perpendicular to that one. To just kind of show you. What was it? Was x equal to 3 and y was equal to 4. So you can see they're perpendicular. So for that special case, then you just kind of gotta best to just kind of remember it. I mean, it does involve taking the reciprocal, but the opposite sign thing doesn't really apply here because this is zero slope and there is no negative and positive zero. There's just zero. All right, so what we got to do here in order to find out both the parallel and perpendicular lines, we have to essentially, oh, you know what? Well, let's finish with this one. We'll take a little break. I didn't realize what time it was. All right, so I'm going to do this real quick. Since we already looked at a couple of slopes, I'm just doing this real quick so we can get the slope and just do the parallel and perpendicular thing. So one negative sign, so the whole thing is negative 10 over 7. So any parallel line is going to have the same exact slope. The perpendicular. What was the deal with the perpendicular? Y'all remember? Opposite sign, and this is a symbol I kind of like to use for a perpendicular slope. Shorthand, right? So I don't have to write out perpendicular. It's going to be opposite sign, so it's going to be positive. So we don't need a sign. And then we take the reciprocal. All right, so let's just take a little break. All right, so we got to remember what that point slope form is. All right. That's the one that looks like this. In actuality, this is really just a different form. This is calling it this point some formula, but it's really the same formula that we used here. It's just solved differently. It's just in a different form. All right. And then they, instead of having y2 and x2, they just got a y and an x that remain in there. And we only replace the point and the slope. So we've got a point and we've got a slope. So that's y minus y, oh, it's right there, is equal to slope of 4 and then it's negative 3. So we got to account for the double negative thing. So they're not giving us a whole lot of room here. So I'm going to have to write small. This is the first problem we run into on this one that's giving us that. So it's plus 3. So that's going to be y minus 2. $12 and then plus 2. And then we got y is equal to 4x plus 14. So that's what we call the slope-intercept form for that particular point and slope. All right, so if we take the and subtract the 4x, then we're more or less in standard form, because standard form is just where the x's and the y's are on the left and the numbers are on the right. Now, some books don't like this, and I don't think that this one does, but in previous, like I said, I've been through a lot of different math books. Some are particular. They don't like to have the beginning x term as negative. So the way you change that is just change the sign of everything. So this is the safe one, and it'll protect you in future kind of scenarios if you go to a different book or something in a different school. But those two things are the same equation. And they're also, if you were to take this and solve for y, you get back to this one. All right, now this is an important concept here. All right. What's the base on number 6? And I want to hear from you on 6a. What's the base? Remember, the base.
6.
Okay, good. And then the exponent is 3, right? It's the little number. Now, over here, the exponent is still 3. Well, what's the base now?
It's going to be 6.
All right. Now, and I'm going to put a C in here for you, because it's important to understand this distinction between this C and B, okay? If the negative was part of the exponent, then you would have parentheses around it. But in this case over here, it was just the 6, because the exponent only affects, it's only an exponent for that in which it's touching. Its base is only that thing it's touching. So in both of these cases, the only thing to be touched is a 6. In this case, the negative just means that whatever that value comes out, it's going to just be negative. So this one right here, the exponent is negative 6. If we wanted to include it, so that's just exponent. It's just done terribly. And then the base, I'm sorry. So this is the base. The exponent is still the same. So the parentheses, if we want something more than just the number it's touching, we use parentheses. You could do the same thing with variables or what as well. So 6 cubed is what? Boy, my brain's not working too well this morning. 36 times 6.
It's going to be 216.
Yeah. Thank you. And this one is going to be negative 216, because that negative sign just assures that whatever comes out gets negated. And then this one would be 216 also. Because, oops, let me back up. This one would also be negative, because negative 6 times negative 6 is 36. And then negative 6 times 36 gives us a negative 216. But that's only because of this being a negative exponent. All right, we're getting close here. All right, so generally with these, you got the same variables. You're going to be able to use the product rule and or the division rule. In this case, all three of these are x's, so I recommend using the product rule first. So in the numerator, it's x, the same base. And this one's going to just stay fourth. And then up at the top, 3 plus 5 is 8. So x to the 8th.
Học đi. Hai coi điện thoại. Không, lấy máy.
So now we're using our quotient rule, and when we divide, we subtract. So this whole thing simplifies down to x to the 4th. All right, so just remember, you got your different rules here. You got the 0 exponent rule. Anything to the 0 power is 1. If you've got a negative exponent, then before you finish, you've got to take an expression is not considered simplified until it has no negative exponents. So if you have a negative exponent, you take the reciprocal. These are the two we were looking at in that last problem. If you're multiplying like bases, you add up the exponents. If you're dividing like bases, you subtract the denominator exponent from the numerator exponent. Now we're going to be looking at these here, and these are very similar because the exponent outside of the parentheses multiplies any that's in there. If you have these that don't have one, that's essentially 1, and m times 1 is just going to be m. So these are almost the same thing. So we got to handle that first. So that means that everything, see, they use parentheses there, meaning that the 6 and the x cubed are the base for that square. So we're going to pass it along to that guy. We're also going to pass it along to the x cubed. And what it's going to do is going to multiply that 2 times 3 there. These, we don't have to worry about these yet. Oops, and there's a y. We'll handle this on the next iteration. Another y. So 6 squared is 36. That's the benefit of having a number to an exponent. You can multiply that out with a variable. You can't because you don't know what x is. 3 times 2 is 6. And then your y up there. And now we're going to go back up to what we did here on the last, except we're going to do it twice with the x's that are alike and the y's that are alike. Now, one of the things you might notice is this is y over y. Anything over itself is 1. So it's going to be 36. And the x is 6 minus 9. And then this is y, 1 minus 1. If you need to do that, I'm just doing it just to kind of show that I'm not getting rid of it or anything. So it's 36. And then this is y to the 0, which is going to be 1. We're just going to leave it off. But this one has got to go in the denominator because that's what the negative means. It means take the reciprocal. So that's it. Remember, the reason why is this right here is equal to 1. And 1 times 36 is just 36. All right, any questions? All right, let's move on. Let's see. Now this one, the one that I have up there in the Canvas, the old one, it's got 25 problems. This one's got 30. The exam is only like 20 problems. You should be able to see that if you go in and click on it. You just don't click start until you're ready to do it. But when you click on it, it'll tell you, you know, the amount of time and the number of problems, and it's 20 problems. All right. So remember, adding and subtracting is just collecting like terms. If it's adding, then we don't need to change the signs of these. But if it's subtracting, we got to change the signs of everything that's being subtracted. So what I'm going to do is I'm going to drop the parentheses, and after we apply our subtraction, we're going to collect like terms. So this is minus a positive x squared, so it's just negative x squared. Here, it's negative and negative, so it turns it to a positive. That's what subtraction does. And then negative, a positive is a -2. And then I'm just going to drop the parentheses on these because these are just being added. And like I said, addition is really just collecting like terms. Now that we've applied our negative sign on this, our subtraction sign, all we got to do is just now collect anything that's alike. Kind of make this a little bit clear here. All right. This one. Well, it changed those things too. I guess I got to click. Anyway, that's 5. All right. So now, the blue ones are alike. So it's 3x and 7x, so that's 10x. Both of those are positive. That's easy enough to do. And then we got a -1, so that's 9 positive x squared. So that's all of the ones that are underlined in blue. Just check. 3 plus 7 is 10, and -1 is positive 9. All right. These are alike. There's only 2 of those for the x terms. I got to remember to click before I change color. This one works different than the other ones I looked at. All right, so now -10x and 3x is -7x. negative 10, positive 3. All right. Let's see. I'll find a different color here. And then the only thing else is left is this and that and this. Those are our constant terms. In other words, those things are all going to combine by the same old basic math rules we've been using. So we got 3 and 5. I'm doing it in that order because that's easier, I think, than subtraction. So 5 and 3 is 8 minus 2 minus 6. All right, now we got to watch out when something says subtract. It's implied that this binomial is being taken away from that one. So we put this one first. So again, what I would do is just collect like terms. Well, first of all, I got to run this negative sign through. So negative 2 and minus a minus is plus 6. Now again, we're going to do the same thing that we did up there, is taking anything that's alike, and that's going to be these and these two. There is no common x squared term. So this is negative 33. That's a squared. Plus 12, 6 and 6. Okay, multiplication. So first, I'm going to start going kind of quick here because I want to make sure we got enough time when we get this done. So b times b is b squared. Outside is b times 2, which is plus 2b. Inside, negative 10 times b, which is just negative 10b. And then negative 10 times 2 is negative 20. And as always, with these binomials, you'll have the two middle terms that combine. So that's going to be b squared and then it's minus 8b. Negative 20. All right. So for both of these next ones, I'm going to take that shortcut. If you got a question about the FOIL, by all means, let me know. But this shortcut works, and I'm going to use it because, like I said, we're running out of time. Well, we may not. We may be all right. So I don't mind coming back. So square the first term. I'm going to leave some room in there, and I'm going to square the second term, which is 10. And in the middle, I'm going to take 3 times 10, which is 30. And I'm going to multiply it times that 2. You can fool it out if you want to. It'll work. Like I said, I'm just taking the quick way. So that's 60z. And what you'll see when you're fooling it out, you'll come out with 2 30z's, which is where the 60 comes from. And there's also a shortcut for the next one. So just imagine that that's up there. All right. All right, well, this one's even got an x squared, but it's the same. This is even easier than that one. This is the harder one. This is what they call the difference of squares. And of course, they leave us the most room for this one since it's easiest, but it's the same thing as, notice that the first term is the same, and it's an x squared, and it's going to be squared. And since the only difference here between the 8y and the 8y here is a negative sign, we put a negative sign there. And then we square 8y. If you foil it out, nothing wrong with that. It might take a little bit longer, but you'll have a positive x squared 8y and a negative x squared 8y, and they're going to go away. You won't have any more of those middle terms. So there we go. All right, so we're doing all right. So any questions? We got plenty of time here. I was a little bit thinking we were going to have some problems, but. Okay, so one more multiplication and a couple of division. Anybody got any ideas about this one? There's no really mnemonic thing. In other words, we can't really use something like FOIL. So basically what we're going to do is we're going to take 9x, multiply it times all 3 terms. Then we're going to take -1 and multiply it by all 3 terms. So what does that look like? Well, that's going to be 9x. There's going to be 6 terms, and then you're going to combine some. Hopefully I can squeeze them all in here. I messed up. It's 9x. And like I said, I don't know how to delete that. it does it. So it's just, oh, there's how you do it. But I probably deleted some stuff up there, so you have to go back and look at it on the video. All right. So 9x times all three. They're all positive 9x's, so I'm using the positive symbol. Times negative 3. And then I'm going to come down here and write it because there's not enough. And then -1 times each one of those three. So everything over here is getting multiplied twice, once by the 9x and another time by the -1. Got to get your signs right. All right, so let's see if I can just keep going here. So that's 9x cubed. Three times 9 is 27, right? X times x is x squared. Nine x times 1 is just plain old 9x. And over here, it's just going to change the sign of the x squared. That's all the -1 is doing, is just changing the sign. -1 times -3 is now positive 3x. And then -1 times 1 is just a -1. Now, again, whoops. So this is alike, this is alike. So there's no other x cubed term, so that's just going to go one of those. -27 and -1 is -28. And then these are alike, 9 and 3 positive, so that's 12 positive. And those are the ones that are alike. There's going to be 2 of them. And then you got -1. All done. All right. So on the next 2, it's just dividing. All right, really good, Velshan. I'm glad to see some answers up there. I'll be glad when this week's over. I'm sure y'all will be too. So much stuff to do. My brain's already hurting. All right. Somebody's going to give you all a couple of minutes since we should be able to finish. So it's just going to mean 2 divisions. It's an or. How did I get that thing before? All right, so this is an or. So that's just a crazy or. Like I said, I don't want to risk getting rid of that. Like I said, this thing is a new. So each one of these is getting divided by 9r. All right. So that's going to mean the only thing we can do is simplify that. That's really 2/9. There's nothing else we can do. Oh, I'm sorry, it's 27. 27 r to the 8th. So that's 27. So 9 into 27 goes 3 times. And then it's r to the 8 minus 1. I'm trying to take some baby steps here. Make sure I don't make a mistake. And it's a negative sign. And then 45 divided by 9 is 5. And then it's r 5 minus 1. So what does that give us? Well, I'll just put it right here. 3r to the 7 minus 5 r to the 4th. All right, so last one. So it looks like you came pretty close now, Sean. I'm not sure what you did with that. Because when we divide, and there's no more fractions. All right. So I'm just going to set this up again. It means do it 3 times. And then it's positive divided by negative, so I'm going to put a negative there. So each one of them and that's negative divided by negative, that's going to be a positive. And it's 12. And this is going to be one of those negative exponents, so we're going to have to handle that at the end. So it's negative divided by negative, so it's positive. I know it kind of looks like I'm not divided by the same thing, but I'm doing the sign at the same time. Boy. So negative divided by negative was positive. So 3 into 18 is 6. 5 from 7, yeah, is 2. And then this is negative. 3 into 15 is 5. Now, x5 over x5 is just 1. So if you wanted to do it, it's 0. So that's just going to be negative 5. So Valshon is right. 3 into 12 is 4 times. And it's x3 minus 5. And I'm doing this just to be careful here. All right. So let me just go ahead and clean it up here. So that's just 6x squared. And it's just minus 5. That x to the 0 is 1 by the 0 exponent rule. Now, what this means is here, I'm just going to show you off here. 4x to the negative 2. So that means that it goes, the negative exponent goes to the denominator because it's the reciprocal. They're going to always want you to write in simplified form. All right, so any questions? All right, so we got a weekend coming up, but you got a bundle of stuff to do because you got to finish this test by tomorrow or the exam, okay? And please make sure you don't wait. I got students that still saying, oh, I can't do ProctorU, but the ProctorU should have been done ages ago. That was the whole condition you staying in the class because there's no way we can get around that. So if you go into problems, you're going to have to call the My Math Lab tech support, but it's all very simple. It's just go to the, make sure you got a ProctorU account. Once you created your ProctorU account, you come back to My Math Lab, and there you handle your you click on the test, log into your, well, you got to do the extension, the ProctorU record extension. And once you got that, then you can log into your My Math Lab account. You got to hold up your ID, your calculator, so that way we know who you are and stuff. Because they want you to verify your ID. Because if they don't see your ID, they flag it and they send it out to the department. All right. So make sure you do that. And if you do anything else weird, like I said, I wouldn't use any other calculator because you should show that, declare that a calculator, and then and just, don't try not to talk. I mean, I know some people maybe talk to themselves, but try not to talk because they'll flag you for that. All right. You got to be in the room by yourself because I've had people do some weird things. And that's one reason why I had that trial run on that last test, is just to show you. And I don't think anybody in here had any issues. I can't remember, but I think everybody in here did all right, because I would have sent it to you if there was an issue. Because like I said, that's all watched, and that goes out to everybody. All right, so I'm here until you, and if you got any questions.
See, I thought we had to just identify our face because when I was setting it up, I had they told me to put my face in the camera.
Right, they
But
got to do that. They match it to the ID.
okay, so I would have to put the ID in first, then match my face with the
Well,
ID.
I think
Uh,
that's what works. That would make most sense, but you can probably do it whatever in any order because they're going to take a picture of your face and then they're going to compare it to the ID at some point.
okay, all right.
That's what they're doing. So if they just follow instructions, because I think they give you the instructions, don't they?
Uh,
Maybe
yeah,
I'll,
but I didn't like when I did the pre-test one. They didn't say anything about a
well, the pretest one is just to make sure you got it set up right. Test
right.
two was the
Yeah, the
trial
try.
run.
Yeah. When I did
Yeah,
that,
the pretest is just to make sure that the thing works. You know that you got your app or your extension set up. That's all that was. So I don't know if they'd actually go through the whole procedure, but I can't remember. I wish they had it to where I could go in as a student. I've just seen a video of how it works. So, and I get, the instructions are in there on in Canvas on their home. But if you didn't get an email from me after chapter 2 test, then you should be all right.
I did, but it was for because my ID. That's
Yeah,
it.
ID. Yeah.
Everything else was that was it.
They want to compare your face to the ID. That's all it is. So just make sure you do that. Show your ID. If you don't see it, then show it up. But I think that you might have missed a prompt for it. Is what I'm thinking. Because actually, I didn't have anybody else with that issue, so I don't know why. What other reason it would be? All right, so when I see you on Monday, we're going to start chapter 6. So I'll be putting in using Friday to be getting y'all's midterm grades. So you'll know where you stand in the class. Because I got to go through there and clean up the grade book and all that. If anything has been left undone, that's going to turn to a pumpkin. So part of what we're doing at midterm is just to show you how it's going to be at the end of the semester.
Okay.